Hello, welcome once again to Physics Meal, a wonderful and lovely program that is designed for all students, especially you that is watching the program now. Today on Physics Meal, we are going to look at measurement part 5. You remember that in the last part of our concept of measurement, we gave some questions for students to practice, and in this part 5, we are going to solve the questions. So follow me as we do the corrections of the questions that we gave out in our last class. So let's begin. We're asked to find dimensions and units of energy, work, and pressure, given that energy is mass times acceleration times height, and work is force times distance, while pressure is force over area. Now, you remember that I said you cannot find the dimension or the unit of a quantity if you don't know the formula for finding the quantity. So the dimensions and unit of a quantity cannot be obtained if you don't know the formula for calculating that quantity, or the formula where such quantity is available. So we have been given the formula for energy, we have also been given the formula for work and also pressure. So we're going to use the given formula to find their dimensions. So we begin with energy. So let's solve that. We are told that energy, the first question, has to find the dimension of energy, given that energy is mass times acceleration times height. Now, in the steps, if you watch, I think it should be part 3 of the concept of measurement. If you watch that video, you are going to see the steps in finding what dimensions and units of quantities. So it's necessary that you watch from the first part, measurement 1, measurement 2, measurement 3, and even part 4 before you get to this 5th part. So we are told that if you want to find dimension of a quantity, the first step is to write the formula for finding that particular quantity, and then you ensure that the quantity is the subject of formula. So when we look at this, we discover that this is the formula for finding energy, and energy is the subject of what? Of formula. Energy is the subject of formula. Then the next step is to write all other quantities in terms of dimensions of the fundamental quantity. So the dimension of mass, so we're going to write mass, acceleration, and height in terms of dimensions of the fundamental quantity. So dimension of mass is m, dimension of acceleration is length per time squared, and dimension of height is L. Why? We say that height, breadth, thickness, amplitude, distance, displacement, all of them are the same thing as length. So height, we have the same dimension as what? As length. So after that, we now simplify to obtain the dimension. So if we simplify this particular expression, now we will have m L square over t square, because L times L will give us L square. Now we have other ways of writing this. I can still write this as mass length square per time square. So this is this line. Or if I apply the law of indices, this becomes length square t raised to power minus what? 2. So the dimension of energy can be in this form, or in this form, or in that form. That's the dimension of energy. So that's the dimension in simplest form. You remember from indices, when this comes up, using the law of indices, the denominator in any fraction, when it comes up as a numerator, it will carry what? It will carry a negative power. So that's why we have this minus 2 here. So let's get the unit. This is the dimension of energy. So let's get the unit. So we replace each dimension using the appropriate unit. So we use the appropriate unit to replace each dimension. The unit of mass is kilogram. The unit of length is meter, and this length is squared, so this meter should be squared. And the unit of time is seconds. This time is squared, and this unit should also be squared. Or we can write it as kilogram meter square per second square, or kilogram meter square per second square. So that's the unit of energy. But let's make this statement. The SI unit of energy, the SI unit of energy is joule. That's the SI unit of energy, joule. SI unit. So what it means is that 1 kilogram meter square per second square is equivalent to 1 watt, 1 joule. So 1 joule is 1 kilogram meter per second square, meter square per second square. So kilogram meter square per second square is the same thing as what? As joule. So the dimension of energy is this, the unit of energy is this, while the SI unit based on the standard unit. You remembered in the second part of measurement, when we treated the dimension and unit, we explained that all the units we'll be using will be based on SI unit, the global standard of unit. So the SI unit of energy is what? Is joule. So that's for energy. So let's take the next one, work. Let's take the next one, work. Because of space, we have to tidy this. Let's take the next one, work. Okay. The second quantity here is work. So work. We're told that work is force times what? Times distance. Okay. So having written the formula, we need to replace the quantities using the word, the dimensions of these two quantities. So the dimension of force, we need to use it to replace force. We use it, the dimension of distance, to replace what? Distance. So what is the dimension of force again? Force is mass length per time squared. That's force. And distance is the same thing as length. So distance, we have this. So someone will be wondering, how did we arrive at this? If you have watched our previous videos, you will not have problem. But for emphasis sake and explanation sake, force is mass times what? Acceleration. And mass is m times acceleration is length per time squared. And somebody will still ask a question, how do we know that acceleration is length per time squared? It's because acceleration is change in velocity over time, and dimension of velocity is mass over length over time, then all upon this time. So by the time you evaluate this, you will now know the dimension of what? Acceleration. So if you really want to understand this more, make sure you look out for our videos, the first part, second part, third part, up to the fourth part, because this is the fifth part, and we are not done yet. We still have more to do concerning what? Measurement. So if we do this now, mass times this will give me mass times this. Okay, this acceleration, this force, but we are interested in this, so let's wipe this because we are not interested in force. We just wanted to show how we arrive at this as force. So this times this will give me ml square over t square, because length times length will give me length square. So which I can still write as ml square per t square, or ml square t raised to power minus 2. That's still per t square. Now do you notice that work and energy, they have the same word, they have the same dimension, as you can see. So work and energy are dimensionally the same. They have the same word, the same dimension. So the unit will now be kilogram, replacing the unit with, using the unit to replace the dimension. So meter square all upon second square. Or I can write it as kilogram meter square per second square, or kilogram meter square per second square. In the same way, we have said that the SI unit of what? The SI unit of energy is joule. In the same way, the SI unit of work is what? Is still joule. It's still joule. So it now means that 1 kilogram meter square per second square is the same thing as 1 watt, 1 joule. Wow. So you see, the principle of dimension analysis is very simple. Finding dimension of quantities is not a difficult task. Okay, finally, let's look at the third question. So if you are watching this, if there is any place you made mistake, you start taking note of the mistakes now. Start taking note of the mistakes, and then you correct the mistakes. We are asked to find the dimension of pressure, given that pressure is force divided by what? Area. Force divided by area. Okay? So we need to write the dimension of force and write the dimension of area. What's the dimension of force again? Force is mass length over time square. That's force. Just the whole of this represent force. So force over area. Let's write this T. So this force all upon. So pressure is force, which is this is the dimension of force over area. What's the dimension of area? Length square. So for me to simplify this easily, I need to use the principle of mathematics properly to avoid confusion. So this becomes mass length over time square, which is force, divided by length square. You know, that's what it's going to be. Force divided by area. So this is force divided by area, because area is length what? Squared. So in mathematics, when we change division sign to multiplication, the next term there will be inverted. So we have ml over t square times 1 over what? L square. So when we change division sign to multiplication sign, we are going to have what? The inversion of the term after the division sign. Now, look at this again. Some of us will be tempted to just multiply this and leave it as it is now. So someone may decide to do this, to have ml, because this times 1 will still give us ml, and then we have l square t. Someone may say, oh, this is the dimension, but you have not simplified it. You have not simplified it. You can still simplify further, because L can divide L. You remember that L square, so having M L over L square T is something as saying M L over L times L, then times T, because L times L, that's what we give you what? We give you L square. So you can split this so that this L can divide this L. We are left with one L there. So you see, I can simplify this as ML based on what I have done here now, expanding this, so I have to divide L, so that I'm left with M. Now no more L here. Remember, we just simplified this, so I will have only M divided by, I still have L here, and then I have what? T square. Right, so this is T square, sorry. So I have T square. So, like we have here, that's T square. So, ML over T square times L. Now, leaving it like this is not in simplest form, because we still have a common factor. L can divide L. So, if you leave it this way, you are not correct, because it's not yet in simplest form. But based on what I've done here, I have to expand L square. When I did that expansion, I was able to cancel out this L and this L, leaving us with one L. So now this is the dimension we are looking for. So the dimension now will be M over LT square, which I can write as M per length times square, or mass per length per time square. So when these come up, these are denominators. When they come up, they will carry negative sign. Just that's mathematical principle. Okay, so that's the actual dimension. So if you leave your answer at this point, at this level, you are not correct. You are not correct, because it's not yet in simplest form, and that's why you have to go further to simplify it to be in this form. So finally, we can now write the unit. Mass is what? Kilogram. Length is meter, and time is second. So I can have kilogram per meter second square, or kilogram per meter per second square. So we have that. But the SI unit, I think I have to clean this now. The SI unit, the SI unit the SI unit of pressure is Pascal. Pascal, PA. That's the short form. So it means that 1 kilogram per meter per second square is equivalent to 1 Pascal. It's equivalent to 1 Pascal. You will hear about Pascal by the time you start studying pressure and the principle of manometry. You will hear about Pascal. He worked so much concerning pressure. So in order to immortalize his name, then his name was now used as the unit of what? Of pressure. There are other units of pressure that you will encounter. So when you start doing gas law, you see so many of them, things like bar, Newton per meter square, torres, PSIG, so many of them, millimeter mercury, atmosphere, centimeter mercury. All these are units of pressure, but the SI unit of pressure is what? Is Pascal. This SI unit of pressure, which is Pascal, can also be written in other form, which is Newton per meter square. Newton per meter square. Because directly pressure is force over area. And if force is in Newton and area is in meter square, so Newton per meter square. But as you progress in the study of physics, you start mastering some of these alternative what? Alternative units. All right. So that's all for the answers to the takeaway what? Questions that we gave in our last video. In part 6 of what? Of dimensional analysis, or the concept of measurement, we'll be looking at how we can actually find unknown powers in a given dimension. Yeah, you cannot afford to miss that particular aspect of what? Measurement. So till I come your way next time, continue to enjoy our meals, both in physics and chemistry and in all the subjects. Remember, I'm still your friend, your brother, and also your tutor, Engineer Ike Okechukwu. Thank you, and God bless you.